Good afternoon. Welcome to our final plenary forum on the future of visual innovation. I'm Jeff Beer. I'm founder, founder of the Embedded Vision Alliance, which has partnered with the organizers of ICIP 2016 to put together the innovation program here. The Embedded Vision Alliance is a partnership of technology companies. We work together to enable tens of thousands of product developers in industry to find practical ways to incorporate visual intelligence into their products. I'd like to invite you all to visit our website and also to come to our conference in May in Silicon Valley, which focuses on practical techniques and technologies for incorporating visual intelligence into products. The purpose of our session today is to hear unique perspectives from industry on visual technology innovation. And I'm really pleased that we have 4 very senior industry executives here with us who have deep experience and insights to share with us on content creation, wireless multimedia communications, visual computing technology, and networked media and telepresence. We'll begin with Hanno Bassi, who is Chief Technology Officer of 20th Century Fox Film Corporation. In this position, Hanno directs the company's technology strategy and technology organization and guides the development of new distribution platforms. He also represents the studio and industry organizations, standard-setting consortiums, and legislative and regulatory bodies. Hanno, welcome.
Hello, everybody. Thank you very much for having me here today. It's a little bit unusual for us to participate in this highly academic environment, but I think I thought it may be a good idea to talk to you guys a little bit about what a movie studio like ours does in terms of infinite innovation and maybe spark some ideas about how we could collaborate in the future. So I've just met Dr. Koo here actually before this talk, but it's remarkable how similar I think our messages are going to be. So again, great to have you guys here, or have me here actually with you guys. Anyway, so just a real quick, I think everybody knows who 20th Century Fox is, so we're one of the 6 major Hollywood studios. There's a list of titles. Obviously, Avatar is the one that we're the most proud of, but we've made a ton of great movies over the years and have the Academy Awards to show it. We're also part of a more global family. So, for example, the Fox network in the US, Fox Sports, obviously all part of the same company. Fox News, don't make any comments to me afterwards. They're part of our group as well, but we also have, a stake in Hulu and Sky in Europe and so on and so forth. So we're a global company. We have Blue Sky Animation, so on and so forth. So a wide variety of global brands here. We're also responsible for The Simpsons, and I'm sure there's a few fans here in the audience. Anyway, so what I wanted to talk about with you guys today is first a little bit about the Fox Innovation Lab, and then a very specific project that we've done there over the last couple of years. And I think the way we approach that project might be interesting for this kind of forum here. So I've been with Fox almost 5 years now, since 2012, and we founded the Innovation Lab in 2014. And so what we're doing there is we want to collaborate with industry partners, but not just industry, also with partners in academia. We have, by the way, a very good relationship with USC, just not with the Viterbi School, but with the film school there. But in general, trying to reach out to different partners in the world, basically, to figure out where is the technology that we're using to reach our consumers, where is that going? Where are we going in terms of image technology? That's obviously why we're here, but also interactivity, integration of social elements, animation, spatial audio, and so on and so forth, all are things that we're kind of looking into. And really the trick for us here is we want to understand what path the technology evolution is taking so that we can actually make sure that once new devices come out, new technology comes out, and consumers are confronted with them, that there's actually content for those right when the devices come out. Because in the past, we've had examples where, you know, a new generation of televisions would come out, for example, and there wasn't really a whole lot of content, which is clearly what has happened with Ultra HD 4K televisions. And I'll talk about that a little bit more. So some of the things we're talking about on the content creation side is high dynamic range, which I'll talk a little bit more about, but also obviously something that everybody is talking about now is virtual reality. Obviously, the content distribution, so Netflix, obviously a great partner of ours. But then also, in addition, going a little bit further, which is what's the overall, you know, consumer experience? How did they acquire the content? How many clicks does it take? How is it presented to them? And then what actually is it that they get to see? And for us, for example, we clearly came to the realization that in this day and age where you have these general purpose devices that can do all kinds of things, not just playing you a video. You can check your email, you can, you know, reach your friends socially and so on and so forth. You can read a book, you can watch a movie, and you know, sometimes we still actually make phone calls on these things, which is what they were used to before. Anyway, so that really drives consumer behavior in a different way than it used to be when a TV could only show you television and a VCR could only play tapes and nothing else. We're living in a totally different world, and that's what we're trying to figure out, where, you know, consumer interaction with that technology actually is headed. And in our innovation lab here, so we have 3 current partners, Samsung, Ericsson, and DTS, and I'll talk a little bit more about a project that we did with Samsung that we're very, very happy with and very proud of. So you guys probably are all familiar with high dynamic ranges. Jeff told me before, and I didn't have to teach you that. That's good. But 2 years ago, you know, in early 2014, high dynamic range technology was really still in the research kind of phase. You had several companies that had some early representations of it. Dolby, Philips, for example. There were a couple others. With actually, and those technologies that these guys had actually really did show the promise of high dynamic range content very well. But the problem was that these were, you know, devices that there was no path to make those into a consumer display. You know, they're fairly thick, very bright, obviously, very good performance, very good quality, but you almost felt like you needed your own little private power plant to run the thing, and, you know, heat dissipation, all these issues were huge problems. And they were also very expensive. I mean, to buy one of those, it was, you know, hundreds and thousands of dollars, which obviously didn't make any sense. At the same time, the CE industry launched Ultra HD and 4K displays. They thought that was going to be the next generation of, you know, entertainment. But the problem with that was that an average consumer, and it's still the case, that average consumers have a very hard time telling the difference between full HD and Ultra HD if it's just about resolution. And especially with our content, which is shot at low frame rates, you could say. 24 frames per second is not a very high frame rate this day and age. The motion blur, the motion artifacts actually totally eradicate any benefits you might have from a higher resolution alone. And that meant we didn't really pay a lot of attention to 4K. We didn't make a whole lot of content in 4K. And so when these TVs came out, there was nothing really to watch on them except for still photographs. And at that point in time, we figured, hey, why don't we go out and reach out to leaders in the consumer electronics industry and see if we can do something about high dynamic range, because that, from a consumer perspective, whoever we've shown this to, they immediately get the difference. And we wanted something new, some next generation quality that we wanted to present to consumers. And so our objective was, together with Samsung, to figure out how can we actually create a consumer display that was affordable but still showed very high quality, high dynamic range content. And by the way, we went beyond just HDR. So we talked about, obviously, as far as HDR is concerned, we talked about the peak brightness that the TV needed to achieve, black levels, but also we talked about a transfer curve, what that needs to look like, white point performance, bit depth, and one thing I actually missed on this chart here is the color gamut. So because we weren't really happy from an artistic standpoint what our movies look like in the BT709 color space. It's actually really interesting. It's not generally that well known that it's a huge artistic degradation between the DCI-P3 color space that we use in movie theaters and what people actually see on their Blu-ray when they're using BT709. And so what we did with Samsung, come up with a new TV. They did this actually in a very short time. And while we still had just 1 or 2 lab samples at Fox, we actually already started grading content on that display. So the end result was that at CES 2015, we jointly announced this initiative, and Samsung actually unveiled a TV that was the first consumer display that could do high dynamic range. That was the JS9500. And at the same time, we had two movies already done in this new format, Life of Pi and Exodus. And actually at that same time, Fox also committed as the first Hollywood studio that we would put all of our future new release content out in this new format. Fast forward a little bit, IFA 2015, then we announced also in collaboration with Samsung the launch of the new Ultra HD Blu-ray format. Basically, that allowed us to really reach the masses and say, hey, here's already a list of, at that time, 12 titles that when that format launched, we had programming available right then and there, so people could actually go ahead and buy an HDR TV and buy a Blu-ray player and get content with it. And by CES 2016, we took this a step further. In 2015, we actually, collected a group of industry players from the consumer electronics part of the industry, content providers, other studios specifically, but also broadcasters, distributors like Netflix, Amazon, Sky, DirecTV, and so on, to really bring together an industry alliance to come up with what the next generation quality standard would be for video content that culminated in the unveiling of the Ultra HD Premium logo, which you're going to see more and more in retail now. And so there's now a multitude of television display manufacturers that produce TVs that bear this logo. And there's content that also has this logo on it. So consumers can put the two things together and say, okay, if I want the best display, I look for this logo. And also if I want to get the best possible version of this content, I also look for this logo, put the two together, and there you go. And we have very happy consumers, by the way, this way. And also, as I said earlier, we also have very happy artists, because the canvas that they're using now with this new technology, the combination of high dynamic range and the wide color gamut, gives them a creative space to work in that they've never had before. The contrast ratio is much higher than we ever had in theatrical, and it matches the color space that we have in theatrical distribution. So our cinematographers, directors are just ecstatic about this new format. So I think this is really a success story. And I think the conclusion basically the takeaway from this is the earlier we get together with academia, with the industry on a new technology, and the earlier we understand what the promise of that technology is, the easier is it going to be for us to make sure that by the time comes and actually the devices are available, that we already know how to make the content for those devices. And by the way, a good example where that I think is needed is virtual reality, which I think, at least in Fox's view, is the next frontier in terms of a next generation entertainment experience. I think VR is going to change the world as we know it for entertainment, and not just for entertainment, for education, for travel, for gaming, for what have you. And so actually we're in the early stages of figuring it out. So my point is, if we align early, if we start the dialogue early, and we have some joint go-to-marketing strategies, then we'll be successful. Thank you very much. Appreciate it. Thank you, Jeff.
Thank you very much, Anna. Next, we're going to hear from Bo Begol, who is VP and Global Head of Huawei's Media Technologies Lab. The lab creates technologies and standards spanning ultra-high efficiency compression, computer vision and hearing, augmented and virtual reality, and full field immersive communications. Bo, welcome.
Thank you very much, Jeff. Well, it's a pleasure to be here in this audience. I have to say this is my first time at ICIP, and I've really been illuminated by the state-of-the-art in technologies and image processing, so thank you all for inviting me. My background is more from human-computer interaction, but I've been recently the head of the Media Technologies Lab at Huawei, and we have the mission of creating media technologies that surpass human perception in speed, fidelity, and realism. Let me see, sorry. So we work on algorithms on video and audio and other kinds of signal data. We focus primarily on compression and quality metrics. And then our second category is media intelligence, where we're doing computer vision and audio intelligence and other kinds of semantic analysis, or semantic extraction from signal data. And the third category is new media experiences and what kinds of technologies are necessary for the next generation of media devices that are coming out on the market. And we've done work there in higher resolution displays. We have wall size 8K and 16K displays. And of course, Huawei's main interest in super high resolution is in the idea of full immersive telecommunication. Exploring this vision of bringing different parts of the world fully together in a way that is indistinguishable from reality, so that people are fully satisfied with telecommunication experiences. So we've all seen this sort of progression of media technologies over the last few decades, from traditional broadcast to streaming video on the internet to multi-device streaming. And then we've added to it semantic analysis of the video and audio data, so we can extract meaning from the content and do things like personal recommendations of media for users. And now we're moving into more immersive kinds of display devices for virtual reality. And next, beyond that, will probably be augmented reality, where we can interleave digital data onto our real-world experiences. And I already mentioned how at Huawei we're also really pushing the envelope on full field immersion, the idea of taking all of the light field and sound field data that exist in the world and putting that onto the wire so that we can have a fully immersive, realistic telecommunication experience. But I really show you this slide mainly to say that we all accept this sort of progression, and I see this as sort of an evolution of media technologies, the natural evolution as computation becomes less expensive and data and network bandwidth, data storage and network bandwidth expand to higher capacities and cheaper prices. So this is sort of evolutionary. And what I'm interested in is what's going to be revolutionary about the next generation of media experiences and creating technologies to enable that and anticipate that too. And this was an infographic that I saw one analyst, Tom Goodwin, put together. And one comment he makes at the lower right there, the lower left, really struck me. Whereas he said the experience is more aware of the viewer. You know, he's pointing out how the screen has gotten closer to the user and the user has become more in control of the experience. Finer and finer grained controls are possible as the screen has gotten closer. But then in this new paradigm of head-mounted displays, the experience also adapts to the user's position in space. The user no longer has to explicitly control the experience. The experience can be adapted by observing the user's behavior and actions in space. So I think that opens up a new opportunity to go beyond these two extreme paradigms of either the fully passive lean-back experience that we get by consuming cinematic video to this fully lean-forward, highly engaged game experience where the user is deliberately controlling how the media is changing over time. There's something in between now that we could start to explore. And also, if you think about too, you know, we've got more advanced AI technologies, and every day those are getting more and more powerful. We're finding new applications for them. What's it going to mean when we really combine artificial intelligence, sensing technologies, and new media formats? So that's what I'm talking about. So first, here's one thing I want to point out is when that analyst described the experience being more aware of the user, I don't think he really intended anything as grandiose as I've painted, but he meant something like this, where now we can have a new media format like a 3D volumetric video. And let me show this video clip in the upper right. If backstage, if you could click on the upper right video, please. Right. Okay. Can you kill the sound? Can you? Okay. So I don't know. Probably most of you have seen that. That's a sample video from 3D TV that was acquired by Intel sometime last year, and they're using multiple cameras, inward-facing cameras, to capture the scene, constructing a 3D model of it, and then interpolating views as the virtual camera pans between the physical cameras, right? And they've been deploying this in sports stadiums in different parts of the world. They have some cameras in the sports stadium near San Jose, and the Super Bowl had a couple of clips that use this technology. So right now, though, it requires a high amount of computation and long post-processing in order to construct the 3D model and then create the virtual camera render as you pan the camera around the scene. And so it takes them, some minutes after the play to actually then show this 3D view. But it won't be long before this technology is possible to do in real time. And once that's possible, that means the users can arbitrarily decide where in the scene they want to position their heads, and they can walk around this 3D reconstructed view of potentially a live event. So if we click on the lower right video, this is just a demo from my lab of what that would mean. We have one of the researchers created a 3D volumetric view. Sorry, could you go back and click on that video? So here he just created a short loop video constructed from 48 cameras in a circle, and then he's segmented out, kind of coarse-grained segmentation, but this was just a proof of concept. And then we're watching that view as somebody walks around the room with a Tango tablet that can perceive the tablet's position in the room. So this is the kind of thing that's going to be possible for people in the future once we are able to make these 3D models and 3D videos in real time. So that's the kind of technology that makes the experience more aware of the user. The user can just naturally participate in the scene and get the experience they want. But I don't think it stops there. I think if we look at how a lot of new sensing technologies are making it possible to infer the user's state of mind, we could take this at least one step farther, and I think 2 or 3 or leaps farther than what we're seeing so far. So this was an article in a gaming magazine last month about eye tracking technologies, and I saw a demo from Fove, the Fove VR goggles, where they have eye trackers embedded in the goggles. And the idea for gaming, especially for first-person shooters, it's beautiful. You could just use your eyes to gaze around the scene, and that changes the aiming point of your virtual weapon in the video game. And you just blast away at everything that's in the scene. You can just glance around and just blow things away. And it's really quite exhilarating. So it makes perfect sense for VR games, and I think we'll see that in those games. Here's a little more nuanced use of eye tracking technologies for a media experience. This was constructed by the musician named Usher, and it was a provocative experience where the idea was you have to stare into, it used the webcam on your laptop to do very coarse-grained eye tracking, and you have to maintain eye contact with the faces in this video in order to hear the music play. And he did this to make a statement and make people think about the people behind some of the gun shootings in the US. And I'm not here to make a political statement, but I think it's very provocative use of eye tracking technology for a media experience. And so he required that you look into the eyes of these people who've died from shootings in order to listen to the music. So eye tracking, though, is just one of many ways that we can infer a person's state of mind, right? You can use temperature and pulse rate to see their sort of valence and agitation level. Expression recognition is a very active area of research. There was a full session on expression recognition and motion detection earlier today. And then head pose, also an indication of attention. Head pose, body pose estimation, pupil dilation, and then also in the audio channel too, we can infer the person's state of mind from their vocal affect and laughter. So all of these component technologies exist, but they haven't really been well integrated, and they also haven't been used to follow what's the interaction model that humans use in a conversation, for example. And what do I mean by that? Well, what I mean is advertising today is very blunt, very in your face, right? You see the ad and it pops up on your screen or beside the text you're trying to read. But if you walk into a retail store and engage with a human salesperson, they're much more subtle. They'll try to get your attention like ads do, and if you don't want to be bothered, generally they'll back off. The good salespeople will anyway. If you don't mind the approach, then they'll try to help you help understand what your goals are, what your need is. And then they'll do this matching between that and the products they have. And even if they don't have products that match exactly, they'll try to map it into your problem space. And if you are still engaging with them, they might take it further and talk about other problems that this product solves. And finally, they're going to drive to close a deal. And my point is that there's this semi-structured human interaction model for sales that our systems today aren't really taking advantage of. And that's true for all kinds of human-to-human interaction. So if we can couple these engagement detection techniques along with human-to-human interaction models, we can then start to see more conversational kinds of media experiences. So emotion recognition, I already talked about that, and we've all seen examples of it. Here's another example of what I think is going to be the future of responsive media. And this was a demo at the CHI conference in San Jose in May from the University of Nottingham. And what they've done is they've outfitted the viewers with a NeuroSky EEG sensor that they put on their head, and that gives a coarse-grained measure of brain activity. And they use that along with the eye blink rate, which they can also sense with this headset. And what they've created in the content is a piece of content that has 4 different channels. And the channels are, the story is about a child, a boy who has a traumatic experience. He discovers a dead body when he's riding his bicycle to school one day. So it's kind of a short piece. But anyway, it's this traumatic experience, and then he's living his life while this is very much on his mind, this experience he had. So the 4 channels are, there's a video of the real experience from the boy's point of view, then from a third-person point of view, and then there's 2 channels which are sort of his imagined emotional experience that's not based entirely on the reality, but it's how he's reacting to it. And as the viewer is watching the content, it's monitoring their brain activity and also their eye blink and switching between those layers to try to maximize the person's engagement with the content. And I wish you could experience it because it's really quite powerful. So here's where I think we're going. We've got these new component technologies, and if we can pull them together and think about new disruptive ways of creating content that really leverages the user's engagement, then we can find these really powerful new media between full lean back and lean forward. Things that can watch our eye tracking and our arousal levels as media is being presented to us. So ultimately, where I think this could go is to create experiences that are fully synthetic. So if you imagine, for example, a fantasy football league where the games are played by simulation, and the simulations adjust the state of the game to try to maximize the arousal of the viewers, then we may see a whole new kind of football league that's in just the virtual world. So here's my concluding slide, is just to think about this new capability that we have with sensing technologies and new multimedia content technologies that can be deployed across all kinds of devices, large screens, mobile, augmented reality, but it also applies in vehicles too, as people are now, between now and when we get to full autonomous vehicles, we have the semi-autonomous vehicles, and we sometimes need to engage the drivers to maintain alertness to the roadway depending on traffic conditions. Well, we can use media to try to increase their engagement with the environment. And then of course there's robotics and intelligent tutoring systems too that also can be enhanced by measures of human engagement with the media. So I just want to leave that vision with you to think about as one of the branches, disruptive branches for media technologies in the future. Thank you very much.
Thank you very much, Bo. Very interesting indeed. Our next speaker is Raj Jaluri. Raj is Senior Vice President of Product Management for Qualcomm Technologies, Inc., where he's responsible for managing Qualcomm's Internet of Everything, mobile computing, and 3D fingerprint technology businesses. Prior to this role, he was responsible for Qualcomm Snapdragon application processors. Welcome, Raj.
Okay, thank you very much for having me here to talk at ICIP. I actually have been to ICIP before, unlike the other 2 presenters, but that was probably when ICIP first started, when I actually published a paper here, or maybe a poster, I don't remember. But I haven't been back in 20 years. But it's fantastic to be back and look at the conference and all the progress we've made. What I want to talk about today is actually a little bit of about computer vision and where computer vision started and where we are today. And listening to the 2 speakers before talking about virtual reality and augmented reality, and particularly the kind of experiences that we can expect to have in the future. At the heart of all these things is actually the chips that need to deliver that, and I spent a career building processors. So I'm going to try and give you guys a little bit of insight into what kind of processors and what kind of compute is required to actually make these things happen. And that's going to be bulk of my talk. I'll talk, if you look at computer vision and if you look at all the areas of computer vision that actually now are out in the market, mobile imaging, mobile phones, VR, AR, IP cameras, robotics, drones, automotive, a few applications where vision is pretty much indispensable in these applications. And And actually, ironically, a lot of people and a lot of people in academia don't quite realize how much of the work they've done has gone in to make these products possible. If you look at your smartphones today, people don't realize how much computer vision technology we have packed in into a simple thing like camera, for example. You take a camera and take some pictures or videos. The electronic image stabilization that works there is actually vision techniques that we developed over time. Panoramic stitching, the auto exposure, auto white balance problems. All the things we do to make a great picture come out is actually tons of computer vision techniques in there. And I actually think mobile phones has been one of the premier examples of where computer vision technology has really revolutionized the picture taking and sharing capability. So what I wanted to do today is to talk to you about some of these other applications that are not so obvious and are just at the beginning of taking off, and particularly because of the work we've done in building these processors for mobile phones, we have these implementations of computer vision techniques that will actually change how some of these things work. What I actually wanted to do was spend maybe the bulk of the talk on VR. There's a lot of hype about VR, and it is real. I mean, if you guys experience VR headsets, the experience is so immersive that till you actually use it, you don't realize what a game changer it's going to be. And these are just the first generation of the products. And you can just imagine 5-10 years from now the kind of products that will be out there and how immersive it will be. So I want to spend a little bit of time on VR, but before I do that, I wanted to talk a little bit about why is it that computer vision, which we've been working on for many decades, is now suddenly, in the middle of all these products. I think there's a few things that made it possible. One is, this is just looking at mobile processors. If you just look at the amount of computational power that's actually in one of these phones that you carry around with you, it's from the first version of the phone to now, there's 85x improvement in compute. That's actually a tremendous number. You don't really think about that. If you look at the memory, just from 2009 to now, there's 16x improvement in bandwidth. And the camera sensors, you can see the resolution improvements. And the last one is actually kind of a catch-all for the kind of picture quality that you get out of this camera phones from when we started in 2002 to 2014. It's tremendous how good the quality is that most people don't buy still cameras anymore. And that's been made possible because of these improvements in compute, memory, sensors, and optics. Now a lot of these applications are possible, which we never thought were possible when we were working on these algorithms 20 years ago. And it's an important thing to communicate to this audience here, because I think what I'd like all the researchers and students to think about now is, what kind of algorithms should you be working on if we keep up its rate of increase for the next 20 years? I think most people don't think about it that way, and I definitely didn't think about that when I was working on grad school, and I think that's an important point. So now I want to talk to you about this particular product, which is virtual reality. Now, I don't know how many of you have used a VR headset, but typically when you put on this VR headset, whether it's Oculus or the Sony Morpheus or the Vive, there's a bunch of stuff that happens to make that experience so real. Firstly, you have to track the head motion and the eye motion in these headsets. And then you need to have the ability to detect gestures if you're doing something with your hands, because now you have this thing that's over your head, so you can't really see your hands. And object tracking, and you need to track the scenes in the objects, in the scene. You need to track the objects in the scene. And to really get a great immersive experience, you need to be able to reconstruct the scene in which the person is sitting, to the points that the speaker before me was making, to make these kind of things where the experience is neither lean back nor lean forward, but actually something in between where the content adapts itself to how the user is. You first have to be able to understand the user and the environment in which the user is. And that takes a tremendous amount of computation. And I'll walk you through a couple of things that happen in a VR headset. Firstly, you have to compute what's called a 3DOF, which is the 3 degrees of freedom of the head, to see which way the head is moving. But to get a real immersive experience, you really have to solve the 6DOF problem. The 6DOF problem is, not only your head can rotate in 3 degrees, but you can translate into another 3 degrees of freedom. So now there's 6 degrees of freedom. Now, most of the virtual reality headsets you buy today only solve the 3-DoF problem. What happens is you have to like sit in one place and you can move your head, but you get up and start looking at stuff, it doesn't quite do the same thing. And the other thing is most of these things, the virtual reality headsets today expect you to structure the environment by putting either dots on the headset or putting markers and have cameras look at it to figure out where the head is. But with the amount of work we've done in computer vision, we can actually, with a single camera, compute the 6-DoF. And if you look at the previous slide where I was showing you a picture of a virtual reality headset, that's actually a headset we built at Qualcomm as a reference design. We just launched it a month ago. With one single camera, we are now able to look at the scene, compute the feature points in the scene, calculate the motion and the 6 degrees of motion, and cast it into a Kalman filter. So we actually can do a complete VIO in one camera on the processor in the headset. That's actually how much performance there is in these processors. So now you can just wear this and walk around the house and you'll have a complete understanding of the scene and calculate it. So here to do that, you need to do camera feature processing, which runs in the DSP. You use the accelerometers and the gyroscope to give you a little initial position, and then you calculate the 6-DoF. Now, it's easy to say you need to calculate that, but the other important point in virtual reality is there is a key parameter, which is basically called the motion to photon latency. When you move your head, as humans, when you move our heads, the scene, changes in our view with the head motion, but the latency from the time you move to time the new scene is, displayed has to be less than 20 milliseconds. Otherwise, you're going to get sick. That's why the initial virtual reality headsets didn't quite do it. So actually now, with these processors that actually in these virtual reality headsets, we can do the motion detection, we can do the visual processing, we can do the display, all under 20 milliseconds while calculating the 6-DoF. And we can do that in a portable battery. It's actually amazing the kind of processing that goes into this and what we're able to do today. If you extrapolate that in another 10 years, you can kind of imagine what kind of experiences we can build. And this is another concept of what we can build in a few years, which is not only can we compute 6-DoF and VIO, but we can actually do SLAM. SLAM, of course, is simultaneous localization mapping. Now, if you have enough cameras, enough sensors, enough processing, you can simultaneously localize where the person is and map the scene while computing the 6-DoF and while doing the 3D display of the content. And we have demos of this now on our process, and we believe that it's very much within reach. When you do that kind of experiences, that's why so many people are excited about what virtual reality can be, because we are now at a stage we have processing capability that can enable these kind of experiences. I'm going to switch gears and talk to you about a different topic, and I won't go into as much of a detail. But if you look at drones today, there's a lot of excitement around drones. And the reason there's a lot of excitement about drones is with the process and the technology we built in computer vision and image processing, over the last 20 years that you guys have been doing in these conferences, we can now build autonomous takeoff, we can build position and hold, we can build 360-degree obstacle avoidance, we can do visual initial odometry, as I showed you, and do follow me, where the camera actually tracks the person, and we can do a full digital gimbal, so you don't really have this mechanical things moving, and we can do return home on a drone, all on a single processor that's on the drone today. So this is actually another exciting area. And I won't go into all the details of that, but you can see here all the kind of things that work when you do that. Another area is cars. And most of you have probably seen autonomous cars and the talk about autonomous cars. That's another area that is tremendously going to take off tremendously in the next few years as we put these computer vision techniques, not just computer vision, but multi-sensor fusion. An area that we've been working on for a long time in research, but the first results are coming in when we combine LiDAR and radar and the sensors, what the car of the future will be. And those of you who live in Silicon Valley or Mountain View can actually see these Google cars running by, and they do work, and it is actually within reach. I'm going to spend a couple of minutes talking about what is it that has happened in compute, and what are the kind of compute architectures that actually enabled these kind of applications. The first thing we found is that computer vision, is one of those things, is a lot more than image processing. And you really need architectures that are completely heterogeneous. And what I mean by that is you need a camera engine, you need a video engine, you need a heavy amount of signal processing like a DSP, You need vision processing units that actually process computer vision stuff, GPUs that actually do things like deep learning, and CPUs that do the general purpose algorithms to do decision making. And we need high amount of memory bandwidth. This is actually kind of like a high-level block diagram of what a smartphone processor that's in your latest smartphones. This is the kind of architecture that will be there in many of the new vision applications, because those applications that I talked about have very, very similar requirements. GPUs, CPUs, video engines, camera engines, and so on. And to make embedded vision happen, you can just extrapolate a processing structure like this and give it the 10x, 20x, kind of acceleration that I talked about in the first slide, and you can see in next 10 years where we could be in terms of vision applications. So it's really exciting to see what we're able to do now, and it's almost been like a switch that now we are able to actually bring these applications to a full performance, and in commercial applications. So just some closing thoughts. I think, as I mentioned, the advances in compute, memory, camera sensors, optics, have really made vision reality in many of these applications, and you see them today. Drones, AR, VR, surveillance cameras, automotive, smartphones are really some of the key areas that we are seeing, but there are many more like robotics and so on that are right around the corner. The real key innovation is to really have heterogeneous compute. That's something we realize now, that one compute architecture doesn't really do a full vision problem, and which means you need GPUs, CPUs, DSPs, and so on, and you need to couple them effectively to really get to this performance. Thank you.
Thank you very much, Raj. Super interesting presentation. It's really interesting to see the story that all of these presentations are weaving together about the whole ecosystem required here to ultimately deliver value to users. Our final speaker in this session is Susie Wee, who is the Vice President and CTO of Networked Experiences at Cisco Systems, where she develops technologies and architectures for software-defined networks and contributes to Cisco's unified platform strategy. She also develops technologies for augmented collaboration and co-creation. And prior to her current role, Susie was the VP and CTO of Cisco's Collaborative Technology Group. Welcome, Susie.
Great, thank you. Hi there, everybody. It's great to see you all. I've been a longtime member of ICIP, although I haven't been here in a few years, so it's good to see all of our old friends again. In fact, I was at the very first ICIP many years back. So today what I would like to talk about is the next wave of visual innovation and visual microservices in the Internet of Things. So first of all, it's kind of useful to go in history. I guess one nice thing about being older is that you can look back and look back at some of the transitions that have happened that many of us have been through. So if we kind of think about the evolution of digital technologies, we started with IP networks, and we were kind of, many of us, some of us, not all of us, are the last generation of people who have known the world before the internet existed. So there is the IP networks going from host-to-host communication to the World Wide Web, to remembering the first time you could actually do voice and video over IP, which was incredible. Then it moved on to handle digital video and HDTV, mobile devices, and social networking. And now we're in this world of a digital convergence where we have things like software-defined networking, cloud, containers and microservices, the Internet of Things, and big data and real-time streaming analytics. So there's a lot that's going on in this new world, which means there's a lot of places for us as a community and the visual innovations to really innovate. So what I would like to do is talk about visual innovations in terms of kind of three different areas. So first is visual and IoT experiences. Next is what's happening in cloud services and network services and things that we can leverage. And then finally, developer tools and platforms, because what happens is the tools are different and the rate of innovation is so much higher because of these tools. So first, to look at visual and IoT experiences, there's actually many different types of aspects. There's people-to-people experiences, people-to-machine, and machine-to-machine visual experiences. And so just to look at some of them, again, going back in history, is if we just go to 25 years ago now, there was kind of the transition from analog to digital television in terms of the technologies that this community, that we have all created. And then just to think about 10 to 15 years ago, it was a big deal. Now every iPhone and every mobile device has a camera on it. But do you remember the time when they didn't have the cameras and they were just starting to put it on? When laptops just started to get cameras on them as well? That was a big deal. And then to have music in hotspots, like a place where you could go to Starbucks and actually get Wi-Fi and get music services, that was a big deal. But now we're in a different place. We're in a place where the network has evolved, the technology has evolved, cameras have evolved, compute has evolved. So we're in a whole different place. So let me show you an innovation that we did in terms of, this is not a product, but an innovation project to examine how people could interact in a new form of collaboration that we call augmented collaboration. I think there's a little bit of audio. We're developing a new form of collaboration that we call augmented collaboration. And what we're trying to do is break the barriers of working across geographies and let people collaborate naturally from wherever they are. We had a new team that came together. It was different leaders who were working on different parts of Cisco's collaboration business. And the first thing that we did when we formed this new team was have an offsite. You know what kinds of meetings those are, where there's again a lot of whiteboarding, brainstorming, bringing things together. The thing is that we kind of thought about this later and said, we are the collaboration team. We actually build Cisco's collaboration products. Why did we have to meet in person for this meeting? And so that was the start of augmented collaboration. So another key part of the augmented collaboration experience is the shoulder-to-shoulder whiteboarding. So when two people are working together at a whiteboard, then you sit there and you actually work shoulder to shoulder. Sometimes you look at the whiteboard, then you look at each other, then you draw something on the whiteboard, you look at each other. So that's the same experience that we achieved in the augmented collaboration experience. We actually did this by actually having our screens placed at a 90-degree angle. Where on one screen, you're doing your whiteboarding. On the other screen, you actually see the other room and your collaborator. And so when you're looking at the board, you're looking at your content. When you look over your shoulder, you see the other person. So you're getting that shoulder-to-shoulder whiteboarding and collaboration across the ocean. Not everybody wants to run up to the whiteboard to share their ideas. Some people are at the whiteboard. Some people want to sit more comfortably at a set of tables. Some people sit straight in the back of the room. So I even like to go straight to the back of the room. But to have an effective meeting, you actually want to get everybody's ideas from everybody in the room, no matter where they are. So what we've done was we've actually provided an augmented collaboration experience on your tablet. And what this allows you to do is to fully participate in the meeting, no matter where you are in the room and even outside the room. So for example, you can see everything that's going on the board. You can even have your own presentations and share them from your device. You can also do things like actually contribute with sticky notes. So have some brainstorming ideas where you'll actually set up your ideas on sticky notes and then contribute those to the meeting itself as well. So it's really tremendous to think how far we've come with the technologies that have really evolved and just really thinking first about the user experience, what's needed, and using all the technologies that we in this community develop, but to really put it together in a way that makes sense for people. We were fortunate that this project won a Red Dot Design Concept Award last year. Next, so there's, again, lots of interesting visual experiences and IoT experiences that come with this new chapter. But in addition, there have been a lot of changes in the cloud and in network services with the infrastructure itself. But once again, let's take that walk down history lane and just look at just over 10 years ago, about 2003, some work. But even before that, some of you remember overlay networks. When we were first looking at how to take video and send video over IP networks and try to do it in real time. And then the idea was to be able to do this by placing compute nodes on top of the network and then using that to help video delivery. And then from this, you could do things like send a high-quality stream to a big laptop or a big device over a wireless network, but then transcode it down in real time to get a low-resolution network for a mobile device. Now, of course, this all seems so simple and easy when you look at all the complexities of what Netflix and YouTube and many of the other innovations we saw today, but this was a big deal at the time. We also had to really do by hand a lot of things like figuring out how to place those transcoding services within a network. So a client would make a call, make a request to the portal server. It would then contact a service location manager to see which nodes know how to transcode, and then go ahead and do the best streaming according to the resources that are available. But the thing is, when we think about how all of that was done, this is still what we want to do today. We want to look at streams, we want to insert different media services on the network, but we have a whole new set of tools to do this. So first of all, what do we have? We have the cloud. We didn't have the cloud before, at least not by name. So we had a cloud, we have a whole new set of IoT sensors and cameras and bandwidth. But if we think about one level deeper to how the visual innovation is done, these devices are connected to a network, which can provide some network services. These streams can be put into the cloud, which has big data centers that are doing the compute for these different visual innovations. So if we think about it, then we have different video analytics that we could do in the cloud itself. So we have a set of visual analytics and understanding algorithms, many of which are discussed here, that can be done in the cloud on these different media streams. But in the world of IoT and really high bandwidth and low latency applications, and plus a plethora of video that's coming online, we need to do things closer to the edge. So what we have is an ability to look at an IoT edge or fog computing architecture, which allows some of that computing, some of those visual innovation algorithms to be done at the edge of the network close to the devices. So here, once again, what we have is that we have the edge devices. The edge devices, Cisco has a product called IOX, which basically puts compute on those devices and allows containers and microservices, like Docker containers, to be put so that you could run a visual algorithm on the edge of that network. So let me actually show you what this can look like. And I'll be speaking over the video. So we'll actually be using a system where there's kind of cameras everywhere. And then action needs to be taken quickly. Sometimes you just want to extract information from a video. You don't need to send it all back to the cloud. And what you can do is look at video microservices at the edge. So again, we have our cameras. We'll be working on the edge of the network to do some visual innovations, microservices, and send some things back to the cloud. Now, the developer environment's really important. So we actually created a visual IDE. This is a project that we call DevIoT, where you can actually drag and drop your cameras and your IoT sensors onto a canvas. You can drop your network services onto the canvas as well, and your cloud services. And then you can actually plumb these things together. And we know that that's actually not trivial to do, so just doing the configuration to make all of this work is one thing. Now we have an IoT edge microservices architecture, and what we can do is on that edge put some compute into there. So we can actually put in visual microservices like motion detection and text recognition and so on. And this shows an example of that, where we actually have two cameras, one in the back of the room and one in the front of the room. We're kind of coming in, registering with our badges and our faces. and then doing things like object detection, text recognition, face recognition, and then loading people in. So again, these are being done in real time. And as people come in, then we're just bringing that information together as it's being analyzed. And then next sharing some of this information with the other cameras so that we can actually do the face detection on these. Now, I'm showing it happening in real time. In reality, we had to do some extra processing to get the video over and get it all processed. But this is the goal that we're trying to achieve. And we're, again, using this, using visual innovations, using containers and microservices on this. So if we look at this, what do we have? We have a set of visual microservices where there's visual analytics algorithms built into Docker containers that are run on the edge of the network. There's open source libraries that we've used in the algorithms to do convolutional and recurrent deep neural networks, computer vision, signal processing, so we use the open source libraries listed there. Then we used our project called DevIoT to create a simple visual IDE for dragging and dropping, and it's a way to deploy visual microservices and to really create this IoT application and network. And then we used other open source libraries for that. So this brings together a number of domains. So again, the last thing to talk about is that what happens is we actually get a whole new kind of magnitude of rate of innovations because of the developers' tools and platforms that we have. So this is the whole world. I just talked about a set of signal processing and computer vision and deep learning libraries, open source libraries that we use, and there's a whole bunch more. For example, in networking, OpenDaylight, OpenNFV, and others to do virtual network functions and software-defined networking. You know, the other kind of acceleration innovation happens because of this world of containers and microservices, where we can do video algorithms as microservices that can be deployed with tools like Docker, you know, onto different devices and edge network nodes even. And then a set of developer tools that makes this very easy to do for developers, such as DevIoT that I showed you. So finally, I just want to say that my current role at Cisco is I created and I founded our developer program, which is called DevNet. And you know, starting as a researcher, I never expected I'd be running a developer program, but it turns out it's an incredible place because it allows people to learn new areas, learn about coding, learn about new tools. It allows them to code. So if you actually did want to code a video algorithm onto an IOX device, you don't have to buy a router. You can actually run it in something we have called the DevNet Sandbox, which you can set up, rent time on it, and then literally run your algorithms in there. And then what we have is DevNet Creations. And this is an area where if you build something cool using some of the APIs that we have, you can actually submit your innovation and share it with others. Or you can actually learn about these different innovation projects there. So you could look at DevNet Creations. This is all at developer.cisco.com. But just the final note that I want to say is, once again, there's really a whole new stage of innovation, and the algorithms that all of you are working on in terms of, you know, detection, compression, streaming, networking, all of these areas really has a whole new way to impact the systems that people to use because of these new tools in the technology and the infrastructure for coding and for developing. So we have a very exciting world ahead of us. Thank you. Thank you.
Thank you very much, Susie. These were 4 really interesting presentations. I think they give a great sense of where kind of deployed technology is heading and how sophisticated it's becoming, and also how many elements of the ecosystem are required to really deliver it to consumers or users. I'm afraid that we don't have time for a formal Q&A session since we got a late start in our session today, and the buses will be leaving for the awards dinner at 5:30. So instead, I'm going to ask our presenters to stick around near the stage here for the next 10 minutes or so. And if you have questions, please come forward and you can ask them questions directly. And that way we can do some parallel processing. Thank you all very much for being here, and please join me in thanking our speakers for sharing their insights today.